functions chapter in that particularly modulus functions. So these modulus functions are called piecewise functions also. So modulus functions also called piecewise functions. Why it is called piecewise functions? So here in the modulus functions, we will discuss the problems or functions for particular intervals separately. So what we can call the other name for this one is absolute value function. Absolute value function. So this is the way how we will call in different ways: modulus function or piecewise functions or absolute value function. So what is meant by modulus function? Let's we understand in easiest way. For example, if I have any function, if I have a function, modulus function, in this, if I'll substitute positive values or negative values in a modulus function, if I'll substitute a positive value or negative value, the output of this function, we will get positive values only. The output of this function, we will get positive values only. So how can we denote this one is, if I'll take some f of x is equal to some y, let us assume that is equal to mod x. So the symbol to denote the modulus is these two lines. So this is called modulus of x, mod x. So mod x will become plus x when x is greater than or equal to 0, and minus x when x is less than 0. So you may get doubt. Just now you told, so whatever the input we will give, whether positive or negative, the output is only positive values. But when I define the function here, I told it is plus x and minus x. Plus x is when x greater than or equal to 0, and minus x when x less than 0. So here I am showing the output as the negative value. So what it means? See here, I'll take a small example for this. So if I'll substitute x value as minus 2. So x value as minus 2 means x is less than 0 here. So that's why modulus of x should become minus x. Minus x in the main sense, minus of x value is minus 2. That means plus 2. So see, we got the positive value. So that's why when we'll define the modulus function, so we'll define like this. So y is equal to modulus of x will become plus x when x greater than 0, greater than or equal to 0, and minus x when x less than 0. So this is how we will denote the modulus function. And let's see the graph of modulus function. So what is the graph of modulus function is? So just see here, graph of mod function. Graph of mod function. So let's try to understand this graph. So y is equal to mod x we have here. So what I told here is whether I'll substitute x values positive or negative. So I'll get y values only positive values. So that means if I'll take the x-axis and y-axis here, if I'll take the, let's think this is the y-axis and this is x-axis. So when I'll put the values, so 0, if I'll substitute here 0, x value 0, if I'll substitute, y value I'll get 0, x value is equal to 1, y is equal to 1, x is equal to minus 1 also, y will get plus 1 only, x is equal to 2, y is equal to 2, x is equal to minus 2, y is equal to 2. So like this, we'll get in the modulus function. Means when you will draw that on the Cartesian coordinate system, so here we will get like this. So 0 means 0 only. So here if it will take 1, so 1 comma 1, 2 comma 2, 3 comma 3, or minus 1 comma plus 1, minus 2 comma plus 2, minus 3 comma plus 3, like this will give. So if we'll join this all, so we'll get the graph for modulus function is like this. So this is the graph for modulus function. So like this it will be. So this is y is equal to plus x. This is for y is equal to minus x. So this is the graph of modulus function. If you'll see the angle here, so you'll get this angle is 45 degrees. and from here to here, this will be 135 degrees. So hope you understand. So how it will be the graph and what is modulus function. So let's see a few properties of modulus function. Then we will solve the problems. So here properties of modulus function. Properties of modulus function. So let's see. The first property of this one is mod x whole square can be written as x square only. And property number 2 is the root over x square. We can write mod x. So property number 3, mod of mod x is equal to mod of minus x. That is equal to mod x we can write. So property number 4, we can write mod of x plus y is less than or equal to mod x plus mod y. And the fifth one is mod of x plus y is equal to mod x plus mod y if x into y is greater than or equal to 0. And property number 6 is mod of x minus y is equal to mod x plus mod y if xy is less than or equal to 0. So if I have mod x some less than or equal to a, where a is positive, so x lies between minus and a, including a and minus a. So r this we can write like x belongs to closed interval minus a to a. So point number 8 is if mod x is greater than or equal to a, where a is positive, we can write x less than or equal to minus a, or x greater than or equal to a, x greater than or equal to a, or we can write this one as x belongs to minus infinity to minus a, closed interval union a to infinity. So this is the way. How can we write the different ways? So let's see problems based on the modulus function. So here are I have a few questions. So question number 1 is solve for x. Solve for x if mod of x minus 1 into mod of x minus 2 is less than or equal to 0. Less than or equal to 0. So we know if x minus a into x minus b is less than or equal to 0. So x is lies between a and b, provided a less than b. So this is the inequality condition what we know in the previous videos. So that we will see here. Here in the place of x we have mod x. In the place of a and b we have 1 comma 2. So how can we write mod x minus 1 into mod x minus 2 less than or equal to 0 is mod x lies between 1 and 2 we can write. So here two cases arises. So since we have the modulus here, so case 1, how can we take is mod x is greater than or equal to 1. That means x less than or equal to minus 1 or x greater than or equal to 1. So what is the another case we can take here? That is mod x less than or equal to 2. That means x is lies between minus 2 and 2. So let's see draw the real number line for this. So if you take this like this, minus 2, minus 1, 1 and 2. So what they are given here, what we got, x is less than or equal to minus 1. So x is less than or equal to minus 1. Here at minus 1 it is closed interval, and x is greater than or equal to 1. So x is greater than or equal to 1. Here it is closed interval. Next, x is lies between minus 2 and 2. X is lies between minus 2 and 2. That means, so from here to here, this is 1. So both are closed intervals. So if you see the common area here, so this is the common area. So what we got for x. So we can write that x belongs to closed interval minus 2 to minus 1 union closed interval 1 to 2. So this is the solution for the above question. So this is the way how we will use the modulus functions. So next, one more question. So same question I can take like this: mod of x minus 1 by mod of x minus 2 greater than or equal to 0. So how to solve this one? So generally, we cannot, in inequalities, we cannot send this directly to this side. So when we want to send that first we have to decide that whether it will change the sign or not. If it is changes sign, first you have to convert it into the not to change the sign. So how can we convert it is mod x minus 1. So divided by mod x minus 2. I'll multiply and divide with mod x minus 2 here. I'll multiply and divide with mod x minus 2. So is greater than or equal to 0. So this will become mod x minus 1 into mod x minus 2 divided by mod x minus 2 whole square is greater than or equal to 0. So here this now we can equal to 0. So it's not equal to 0. Mod x is not equal to 0. So mod x not equal to 2. So that will get x not equal to plus or minus 2. So remaining if you will solve, what you will get mod x minus 1 into mod x minus 2 is greater than or equal to 0. That means mod x minus 1 is less than or equal to 0, or mod x minus 2 is greater than or equal to 0. That means mod x minus 1 is less than or equal to 1. From here, x lies between minus 1 and 1. X lies between minus 1 and 1. Or mod x is greater than or equal to 2 means x is less than or equal to minus 2, or x is greater than or equal to 2. So if you draw the number line, so here minus 2, minus 1, 1, 2. So x is lies between minus 1 and 1. So x is lies between minus 1 and 1. Here both are closed intervals. So that's why we have to bubble with the full circles. And x is less than or equal to minus 2. Open circle because x should not be equal to plus or minus 2. And x greater than or equal to 2. So what is the common solution here we can write is x belongs to closed interval minus 1 comma 1 union minus infinity to minus 2 open union open 2 to infinity. So this is a solution for this question. So this is the way how we will solve the modulus functions. So in the next class, in the next video, so I will discuss a few more problems based on the modulus function. Please keep watching my videos. Please subscribe, share, like, and comment on my videos. Please don't forget to subscribe. Thanks for watching my videos.